Hello guys, today in this video we will discuss about quantum bits. So what is a quantum bit? A quantum bit is the basic unit of quantum information. In quantum computing we call them qubit. A qubit is equivalent to a classical bit in classical computing. In classical computing a bit can have values 0 or 1. Whereas in quantum computing, a qubit can have values 0, 1, just like a bit, and also it can be in a state where it is both 0 and 1 at the same time. So what do I mean by saying both 0 and 1? It basically means that the qubit does not make up its mind if it is 0 or 1. One way of interpreting this is saying with probability. We can say that the qubit will be 0 with probability say x, say 1 by 3. And if the qubit is 0 with probability 1 by 3, it means that the qubit is 1 with probability 2 by 3. Correct? So this is one way of interpreting it. But fortunately, that is not the case. What quantum mechanics says is that this particular qubit is in a superposition state of 0 and 1, which means it is partly 0 and partly 1 at the same time. Right? So with some complex amplitude alpha, it is 0, and another complex amplitude beta, it is 1. But the moment we look into the quantum bit, into the qubit, things take a different turn. The moment we look at it, we will see not a superposition state of 0 and 1, we will see either 0 or 1. So it is as if nature is saying that in nature's private world, it is having a superposition state. It will be both 0 and 1. But the moment we go down to the quantum level and look at the qubit to see if it is how this superposition looks like, the nature says, no, you don't belong to this place. You are not a quantum particle. So you will either see 0 or 1. You will see a stable state in which we survive. This sounds crazy, right? Nature trying to fool us, nature having a different state than what it shows us when we try to measure it. How is this possible? How can a qubit be in a superposition of 0 and 1 at the same time? How can any particle be at two different places at the same time? Right? That is the magic or craziness of quantum mechanics. I'm not joking about this. And if you try to understand this, if you want an explanation for this, if you ask me why this happens, the answer for you is what Richard Feynman said. If you think you understand quantum mechanics, you don't understand quantum mechanics. It may be beyond our comprehension, ability to comprehend. But however, if we instead of trying to outsmart Feynman and trying to explain why this thing happens, if we accept this fact, if we accept that nature works this way, what we can do is we can think how to harness this property of nature and how can we make use of this to make our life easier. So how or what can we do with it? Let us see an example on what we can do with it. Let us assume that we are trying to guess a 2-bit number. A 1 bit can store two different numbers, 0 and 1. So 2 bits can basically store 4 different numbers, 0, 0, 0, 1, 1, 0, 1, 1. So 2 bit basically means 4 different numbers. So if you're trying to guess this one number out among these 4 numbers, how is it different in quantum computing and how it is different in classical computing. Let us see this example and see how powerful quantum computation is compared to classical computation. In classical computation, the two bits can only have four, at any point of time it can only have one specific state. It can either be 0 0, or it can be 0 1, or it can be 1 0, or it can be 1 1. The problem with that is that each guess we only have one number in the classical bit, or the variable which have two classical bits to be stored. So if we guess, at first we'll guess at 0 0 and we'll ask, oh, is 0 0 the right number that you thought of? If that's the right number, we get it in one try. But if that is not, then we try with 0 1. Right? So worst case, we have to try all the four numbers to guess or make the correct guess. Now, let us see what happens when we are using quantum computing and quantum bits, qubits. Qubit, on the other hand, I can put a qubit in a 0 state, a 1 state, or in a state where it is partly 0 or partly 1. So this partly I make sure that 0 and 1 are equally probable. So this qubit has half a probability of becoming 0, half a probability of becoming 1. So that is a superposition state that it is. It is at the same time 0 and the same time 1. So which means if I put two qubits like that over here, I have 0 and 1 for this qubit, I have 0 and 1 for this qubit. So compare these two qubits, what states are they in? It can be 0 0 because the probability of this being 0 and this being 0 is same, half. So it can be 0 0. It can also be 0 1. It can also be 1 0, and also it can be 1 1. This means I have all the four different possibilities of this 2-bit number captured in these two qubits. So these two qubits have all four different numbers together. So if someone asks me, does this 2 qubit store the secret number or the guess, correct guess? Yes, it has the correct guess because it has 0 0, 0 1, 1 0, 1 1. The number that you guessed, that you have in your mind, should be one of these. So in one go, I have all four captured together in 2 bits. This makes quantum computing way more powerful than classical computing. Because in classical computing, you are limited by states. A bit can be either in 1 or a 0 state. In quantum computing, a bit can be in infinite states. Why infinite? 0 is one state, 1 is another state. And the combination of 0 and 1. I explained one example of 1/2 probability of 0 and another 1/2 probability of 1. That is one state. But it need not be 1/2. It can be 0 is 1/4 and 1 is 3/4. So it's a real number. It's a complex number, the amplitude. Because it's a complex number, complex numbers are infinite. There are infinite complex numbers between 0 and 1. So this qubit can capture infinite number of states. That's an infinite information stored in one bit. So that makes quantum computing way more powerful than classical computing. So with that, I end today's video. I hope this helps you understand what qubit is. I'm sure that there are a lot more questions that came to your mind before, after listening to this lecture. That is quite normal. Quantum mechanics or quantum computing is not trivial. It is counterintuitive in nature. So work more on this, and if you have any questions, please feel free to post it in the comment section. Thank you.